hope to accomplish today is give you a comprehensive code coverage of every way you can use LINQ. While that's not actually possible, what I will be doing is going through the entire extensions library. So if you've never used LINQ, today you're going to get a lot of info. If you have used LINQ before, you're going to get some info you've already seen, but hopefully we'll be able to fill in any holes in your knowledge. So to start off, I've got a training project that will be available out on the file server afterwards. So any examples you see today, just go out to the file server, Programmer 01, training presentations. In addition, I'm making a recording of this video, so if you really want to hear my sweet voice all over again for an hour, you can get that under the Programmer 01 training videos. So, first of all, LINQ stands for Language Integrated Query. That's exciting. Moving right past that, there are several different types of links. And I say types with air quotes because they all use the same syntax. They all implement iQueryable, which is an interface that gives objects a data provider and allows you to actually create your own custom objects that use LINQ if you really want to do so. But that's actually quite complex and way beyond the scope of what we're discussing today. However, four main types are LINQ to objects, which allows you to query collections in memory in .NET, LINQ to SQL, which ties in with ADO.NET and some ORMs, LINQ to XML, and LINQ to data sets. We'll be mostly discussing LINQ to objects today, but again, since the syntax is the exact same for all these different types, you will really be able to do the other types after today. Like I said, I hope today you'll be able to jump right off and start using LINQ after this presentation. So I've got some classes here that we'll be using. Very simple, an employee class, name, years worked, etc. Notice the address is another type of class, and that there's a list of access points, and that there's a function for full name. We'll be using those in the examples. In addition, the access point is nothing but an ID and a name meant to represent just that, an access point. Got some subclasses we'll discuss here later. First thing I want to show you is a shorthand declaration for name types. This is, for those that didn't realize, the one place that there are brackets in VB.NET, although they weren't originally always there. If you want to quickly declare an object and define its properties, you can do so using the with keyword and then open up the brackets, and once you press the period or the dot, IntelliSense will pick up the names of the properties and separate it by comma. You can initialize all of them. This is something we're starting off with because it's used heavily in LINQ. Right here I'm defining several different access points. And here I'm using that same shorthand operation for something a little bit more complex. I'm defining a list of employees and assigning it to an enumerable object of type cEmployee. The IEnumerable is the key interface when using LINQ. Anything that implements IEnumerable can use LINQ because that's where these functions are defined. Again, this is just dummy data here of employees. So quick notes about that shorthand declaration. The class members being initialized can't be shared, read-only, constants or method calls. They can also be indexed or qualified. For instance, the following examples raise errors if you're trying to access the index of a particular list within there, or do an initialization of a sub-object. See there when we're doing .address.city, that will fail. Alright, so moving on to LINQ. Here's a basic operation in LINQ, and it's a simple select. You can see that I've got an object of type IEnumerable with the generic type defined as cEmployee. And if you know SQL, you can start doing LINQ immediately. The key difference is, instead of starting with select, you end with select. You see, LINQ has to know, a LINQ statement has to know from where you're querying in order to determine what type to select. So you actually start with the from statement, that's the very first statement, and the select statement will almost always be last. So you say from employee as cEmployee and list employees, which looks very similar to a for each, where .years worked greater than or equal to 2, select employee. This is going to return an IEnumerable of cEmployees where that where condition is met. So if you can do that, honest to goodness, you can do most everything else. And if you already know SQL, like I said, a lot of this is going to be familiar. So let's look at some other examples. Here's an ordered by. Ordered by statement comes after the where, as we can see here as well. Order by, you determine which property you want to order and simply set that after you write order by. And if you want to do descending or multiple columns, you can do so separated by comma and specifying descending afterwards. This is going to get every employee where their city and their address object is Nacogdoches, and obviously order by descending by first name and then last name. Okay, so here's an example of distinct results. Distinct, like SQL, is just a keyword that you put into your query. And again, since every LINQ query is going to return an IEnumerable, here we're not returning an IEnumerable of C employees, we're returning an IEnumerable of strings. Because LINQ is able to auto-determine city is type of string, and it knows what it's going to return. So here, even though we've selected 5 different employees of different cities, the magic of the distinct keyword, we're only going to prevent Lufkin and Nacogdoches. Here's some useful functions that you'll also be using quite often. Sum, average, min, and max. They do exactly what they say on the box. And once you have an IEnumerable of type whatever, of type integer, double, float, or long, you have sum, average, min, and max on those particular queries. On those particular lists. Now here's an example, the first example of an extension, of using the extension methods as extension methods. You'll notice this query statement, by definition, returns an instance of an IEnumerable. And so doing that, when we wrap it in quotes, we can chain a function on there and call .max. This is the first example of mixing the SQL syntax with extension methods, which you'll be seeing more of. We're going to come back to extension methods in a little bit, but first I'm going to discuss something called an anonymous type. For anybody that's used loosely typed languages, you know what an anonymous type is. It's declaring the object instance without really knowing what type it is beforehand. .NET didn't used to have this. .NET used to be the greatest language ever and was only strongly typed. I'm just kidding. I strongly prefer strongly types after working with JavaScript. However, they are useful, and they are particularly useful in LINQ. And the way you use them is you simply don't say the type. You just say dim my object equals new, and there's that shorthand declaration, new with open close brackets, and within there we specify property names for our new anonymous type. And whatever you type here, that will be the property name. These are full-fledged properties in .NET, so they can be used with binding in WCF and other UI frameworks. Now, I wanted to note, technically this does violate Elliott standards, as in you need to declare your variables before you use them and their type. However, there are some instances where this is particularly useful, and in the one case that I always find myself using is if I have a list of objects in which they're far more complex than what needs to be put to the UI, I oftentimes declare anonymous types that are simply bound to the UI, and essentially it's just a struct that I'm passing information through. Now, one important thing to note is this is a brand new type, so it doesn't have any functions on it. In fact, if you try to use a function like that full name we had on the original C employee, it's going to fail, because this is not a C employee. This is an anonymous type that was created one time with this statement. Any questions about anonymous types? Good, because we're going to be using them from now on. So here I've got an example of taking advantage of anonymous types. Got this dummy array here, selected IDs, and I'm using LINQs anonymous. I'm using anonymous types in a LINQ statement because the LINQ statement, when I declare this first line from employee in list employees, it automatically infers, since this is an IEnumerable of C employees, O employee is a C employee, And because I'm using that from keyword, it automatically infers this is a LINQ statement. I'm going to return an IEnumerable of C employees. This is also an example of how to do an in statement from SQL within LINQ. You want to do the contains method, which everybody I'm sure is already familiar with. So here we've got where selected IDs contains the employee ID. We're going to select a brand new anonymous type and return an IEnumerable of that anonymous type. So here we also have a new concept that I haven't mentioned before, which LINQ does, called lazy loading. For those that don't know, lazy loading is the idea that you don't load something until you need it. LINQ actually does that with all of its statements. It does not run its query until it's used. So if you had an if statement here around this for each and it failed, it wouldn't actually ever run this query. This is important for performance reasons, which we'll discuss later on. However, this simple example prints out the first names from these anonymous types. Grouping. For those that have never used grouping in SQL, it's a very powerful tool that allows you to group sets of data under certain parameters. In this case, the parameter is a column and its unique value. So when we run a LINQ statement here using grouping, what we're going to do is get get the groups of employees based on their unique city. Now here we see a new keyword, into, that's used specifically with grouping, and this is actually an anonymous type that's generated behind the scenes that is that has the properties that we're adding count here, and when we loop through this, we can actually see how many instances of each unique city we're using. Grouping is really useful in SQL, but one of the things that SQL doesn't do, or well, that you have to do with joins if you want to do this, but that LINQ does inherently, is it actually also keeps track of the original objects that are in the group. And the way we're going to do that is we're going to specify the name of the property on our anonymous type where we want to get that from. So here we say into current group equals the same thing that you saw before, group and count. And here's that same loop that was from earlier, but now you can see, here, oCityGroup.currentGroup is an IEnumerable of the employees in each group distinctly separated by cities. So this loop right here does something really useful, which it prints out the count based on the unique city, and then which employees were in that particular city. Any questions about that?
It's kind of like SQL where you have to have the group in the into clause.
Yes. In this case, well, in SQL, of course, when you do grouping group by, you have to have that group by clause. And here in LINQ, that's determined by this group statement.
As a performance question, does it only keep all that data if you say whatever equals true?
No,
Or does it build
no, it builds it all behind the scenes. And performance-wise, the group statement in LINQ is one of the more intensive ones. In fact, that and the order by are actually the two most intensive LINQ statements. We'll talk about that later, but yes, to your question, it is doing all of this in memory, and it's keeping it all in memory until a garbage collection goes and picks it up. All right, so joins. Well, joins, orders, and group bys are the three most complex things, I would say. I'm going to use an example of a join and show you this, but I'm going to end with a little epilogue on joins and why you probably shouldn't be using them. However, just so you know how to do them, what we're going to have here is an example where we have essentially three tables: employees, access points, and then a table that has a many-to-many relationship between access points and employees. So here's a list of all of our access points that is representing the table of access points. We already have our list of employees, and here's a table that represents the joining table, access join. And if you recall, this access join has nothing in it but an employee ID and access ID. So if you've ever used a join in SQL before, again, this is going to look very familiar. You say from our list of employees, join as the access join object in this the list of access join records on the key. And then we join that to the access points on the access ID. So here what this query is doing is I want to see all the names of the access points for employee where their ID equals 3. And if you'll notice, we're selecting from oAccessPoint.name. So it's going to get, it's based on these two records right here, it's going to print out main menu and payroll. Now, like I said it before, joins are expensive operations, just like in databases. You can use them with, I would recommend you use them with extreme caution, or don't use them at all. It's my personal opinion that complex joins be done in DB2 if you're doing them at all. And there is one exception I would say, which is cross-database queries, but I know that our team uses, oftentimes uses data tables and data sets for that, and we'll be covering how LINQ can also be used in those scenarios as well a little bit later. Okay, so here's a union. Again, if you don't know, a union is the combination of two different sets of data. Now, the other thing that you'll see in this is our first example of a true subselect within a LINQ statement. A union in LINQ is oftentimes, in my opinion, not necessary. I feel like, and it's been my experience, that if you're using a union in LINQ, you may not have gotten your data appropriately from the database already. However, there is an exception that I find extremely useful when in LINQ, which is that if I have several different lists of objects, and all of these different lists have actually different types of objects, but they all have the same inherited type, a union becomes very useful at that point. Let's take this example of C full-timer and C part-timer, both of which just inherit from C employee. Now, of course, these would be two different types, and we would have a bunch of different employees in each of these lists, and they would have their particular information. But say I wanted to combine all of them, quite easily, you could say, just select all of them from each different list, and we call .union. That's, of course, going to return IEnumerable, because almost everything in LINQ returns an IEnumerable. And because they share that inherited type, we can say from OEmployee as CEmployee in this subselect, give me the last name of all of them. Or order by the last name, give me all those CEmployee objects. This is a great example of polymorphism in action, in my opinion. I don't have it here, but by the way, we'll get to this in a second, but I want to say just for shortness, you could actually make this much simpler. Actually, I don't know if you can do this, so I may run into problems. Full-timers, .union. Nope, I was wrong. You can't do that. Because we specified, give me the parent type, that's what made this work. My mistake. It's always fun being wrong in a presentation. All Alright, moving on and covering a more complex topic, lambda expressions, or you might hear them as anonymous methods. I'm just going to go ahead and read this because it's a great description from SDN. Lambda expression is a function or subroutine without a name that can be used wherever a delegate is valid. Lambda expressions can be functions or subroutines and can be single-line or multi-line. You can pass values from the current scope to a lambda expression. For anyone that's used JavaScript, you already know what an anonymous function is because they're used everywhere. In .NET, they're a little bit of a newer concept. They weren't introduced until .NET 3.5. Here's an example of an anonymous method or lambda expression in VB.NET. We're defining a subroutine that has a parameter p output a string, and this is a single-line lambda expression where we're just writing it out. Now, the body of a single-line subroutine must be a single-line statement, and when you're using single lines, you don't include the in sub. If you're using multi-line lambda expressions, you do include the in sub or in function. Now here we see an example of a lambda expression that's a function, takes in a parameter, and with a single line you don't have to specify the return statement because the single line is the return statement. There could be nothing else. So whatever you are defining here as your single line lambda expression has to return something, in this case an integer. So this, calling this func increment 1, will take the passed integer and increment it by 1. You can of course define multi-line. Multi-lines don't technically need the qualifier of what they return if it can be inferred from the return statement, but I recommend you put it there easy. It'll make your life and code reading much better. And since these are subroutines and functions, we can actually call them. Now, behind the scenes, these anonymous methods are actually a specific type that's inferred. They're called action and func. Action is a sub, and func is function. Very clear. So instead of using anonymous types, which we were earlier, here we're actually expressly saying the type is of action and it has one parameter of type string. And here's that single line again, and here's a multi-line doing the same thing. And here's our func. The only thing you need to remember is that the last parameter is the return type there, whereas all the other parameters before that are the types defined in the function parameters. A couple notes about lambda expressions. They can't have modifiers, they can't be overloaded or overrides because they're not actually part of an object. Optional parameter arrays aren't permitted. And sadly, generic parameters are not permitted. I say sadly, honestly, that would be a headache. Okay, any questions about lambda expressions or anonymous methods before we move on? Great. Oh, one other small note I forgot. The scope of a lambda expression shares its context. So you can see here, this function is currently part of this the parent main function, this giant function we're in right now, and there's a local variable declared within this main function, and it's accessible because this function right here shares the context of wherever it's located, so it can get int age. So here are some of the previous LINQ examples we saw using lambda expressions. You'll notice that in many of the cases it's much clearer. Any of the keywords that you saw, like where and order by, grouping, etc., those all are actually extension methods behind the scene, and that SQL syntax merely gets translated into those behind the scenes. That SQL syntax is honestly there, in my opinion. I think Microsoft added it to help introduce people to LINQ. It's my opinion that once you start using the extension methods that you'll use them pretty much exclusively, mostly because the SQL-like syntax is just kind of wordy. But I say all that with a caveat. I have found if I am doing a complex LINQ statement, I find that it's often clearer to do it with the SQL syntax, depending on the complexity. And I say it's easier to understand from a readability perspective going back to it. So here you see the where function taking in a single line function lambda expression. Here's an example of right inside of a for each, just going ahead and ordering by last name. Order by is one of the few things that, in my opinion, is less readable in the extension methods, because each property that you want to order by, so if you have multiple properties you want to order by, needs an order by or order by descending, and then each one is followed by a then by and then by descending. So this can get a little wordy, but again, since ordering is one of the more complex operations, I highly recommend you do that in DB2, unless it's a small collection. Here's an example of, most of these are examples of chaining. Here we're doing a select where we're getting the city, and then we're calling distinct on the city, like we saw earlier. And in some cases, like I said earlier, you can combine both forms for readability purposes. Alright, so what I'm going to do now is go through a number of the extension methods. In fact, I'm going to go through all of them. So if you already know them, please bear with me. And I'll go over the first one, which is actually my favorite because it's just so freaking awesome. Select many. This flattens a list of lists. So it takes a 2D array, and assuming they're all the same type, flattens it into a 1D array. Here we've got an example. I want to get all of the unique access points that are in my list of employees. Well, if you recall, on the CEmployee object, the access points was a list. So here I'm going to say select many function omp.accessPoints. This statement right here is going to return a list of lists, but by putting it in the select many, it's going to flatten all of those lists into a single list, and then I'm going to call distinct on them and get the distinct access points. Now, you'll also notice I'm introducing a new concept here, custom comparers. LINQ gives you a number of interfaces, iEquality comparer and iComparer, to customize your sort and equality statements. Like for instance this distinct, you can see that we don't need to do much comparison on access points. We just need to check, does their ID equal the other ID? So we can just return that statement. But you could do something complex here if you'd like. And this will be used as the way to determine whether or not two records are distinct from each other. If you'll notice, this is implementing iEquality comparer of CAccess point. Here's another useful one for small collections, Aggregate. It combines values into a single result, meaning that if you have, say, a list of strings, like we're doing here in this .select first names, we can combine them to where there'll be a comma-separated list. If you'll notice that I'm using some, you've probably already seen this before, I like to separate if I'm chaining a number of methods in my extension methods, I prefer that each one go on a separate line. And of course, by placing dot there, that continues the line. You don't have to use underscore. Now, a note about this. This is using string concatenation behind the scenes. Since strings are still immutable, I highly recommend that you still use string builder for any large things, because of course this is going to be a little bit more data intensive, especially if you've got a giant list. Reverse. Magic. I'm just kidding. This is nice because it actually reverses the order of the items as far as their index is concerned. Sequence equal. This compares two different lists, two different enumerables, and sees if they're equal. So I'm generating two different lists of first name, and I'm calling sequence equal and passing in the second one. It's going to write out both are equal because they're the same. Now that's useful with primitive types, but for complex types, you can again use a compare equality comparer. And in this case, CEmployee equality comparer, I'm just again going to compare the ID, because that's all we need to compare, because we know if two employees have the same ID, they're the same employee. So here, I am comparing two different enumerables of employees, and just when I do that compare, just comparing their IDs. Now this is not only that the contents are the same, but they're in the same order as well. Alright, here are some of the few examples where we don't return an IEnumerable from a LINQ method. These are quick queries, single first and last, or quick queries to get a single item from a given collection. Okay? Now you can see here, from our collection of employees, I'm calling a where statement where emp_id equals 1 and calling single, and it returns single instance of C employee. Now, the important thing to know about this is it is going to throw an exception if it doesn't find anything and if it finds more than one. So I would highly recommend you don't use single, first, or last unless, from a programmatical perspective, you want to throw an exception. From a business rule standpoint, if you're finding more than one or nothing. Now again, sorry, this isn't. No, I wanted to note something. Many of the extension methods actually have a where clause as a Lambda method, so you don't have to call .where .single. You can say just .first and then pass in your where clause. Now, instead of using single first and last, I'd recommend that you use single or default, first or default, or last or default. The nice thing about this is it's going to return null if it can't find the record. It will still throw an exception if it finds more than one. But that's one less thing you have to check for. Or it's one thing that you don't have to catch in an exception. You just test to see afterwards, did my query return nothing? Okay, it didn't find the single record I was looking for. Element at or default is the index operator method. And yeah, you guys know it, right? It's really clear. Count, the nice thing about count, or why it's worth noting, is because it's actually a function, not a property, and it again takes in a where clause. So we can return the count where this clause is met. Any and all actually return booleans based on whether or not their particular clause is met. Okay, so this first one, boolean employees exist in Lufkin, our employees.where the city equals Lufkin.any. Are there any records that meet this clause? Return true. All tests all the records and see if they all meet the particular clause. And again, here we're just using its built-in where clause to say, are all of them from Nacogdoches? No. That returns false. Take while, skip while. Oh, I love these. They're so much better than doing subselects. And that's what they're meant for. So if we have a collection of records and we need to determine, well, you know, I need to parse out something from index 5 to index 10, then we can do that quite easily. The take and skip both just take in an integer saying, well, how many do you want to take from the start of where we currently are? How many do you want to skip from where we currently are? Whereas the whiles actually have to have a condition, so we take all of the records while this condition is still true, and as soon as it meets a condition that fails, one of the records that fails this condition, it stops. And same thing, but for skip, it doesn't start taking them or start querying them until this condition is met. And you can use chaining for easy list manipulation, assuming that they're ordered in a particular order that you want. Here we're giving give me all employees where the years worked is 3 to 9. Okay. Now I'm going to go over some methods that are extremely useful to me, and they have been in the past. This as enumerable is available on actually most collections in .NET, and what it's going to return back, if that collection isn't already implementing IEnumerable, it's going to return a version of that collection. Well, it's going to return an IEnumerable of those objects. And then IEnumerable has several different conversion operations: toList, toArray, and toDictionary. As you can see here, as you recall, almost all queries in LINQ return an IEnumerable, but most of the time we use lists. So this is what you'd want to use to easily convert that to a list. If you're using an array, you can just use toArray. But this has always been one of the most useful things to me. If I've got a list of things and I want them to be a dictionary, you say .toDictionary, and this Lambda expression here is specifying which property do you want to be the key. Now, an important thing to know is, of course, primitive types, it's going to make a copy of those values, but complex types, it makes copies of the references. Again, this has always been extremely useful to me with the dictionary because, for instance, if I have a list of things that I'm binding to the UI but then want to access specific ones later on, I'm not recopying the entire object, I'm just copying the references. So there's still only one set of these objects out there in memory. It's just that I have a list and a dictionary pointing to the same objects. Okay, custom collections. If you have your own collection of objects, some class that you've defined yourself, and you want it to be queryable by LINQ, all you need to do is implement IEnumerable of type T for that collection. So here we've got some type of custom dictionary class. I'm not going to implement iDictionary because that's actually way too complex for this example. Seriously, if you've ever looked at iDictionary, there's a lot of functions you have to implement to make that work. Anyways, so say we have our custom collection of employees here where we have a default item property that takes in an ID, and we're using LINQ to get to use that like a dictionary would. If you want this collection to be queryable, all you have to do is implement IEnumerable of cEmployee, and that's going to create these getEnumerator functions. And since we're already using something that's IEnumerable in the background, all you have to do is call .getEnumerator. If you're implementing your own collection and own enumerator, it's probably more work and you should reevaluate what you're doing because .NET's collections are already pretty powerful. So here, our dictionary, our custom dictionary of employees, we can now call .where on. Okay, link to datasets. I know that the GUI team uses data tables and datasets a lot more than the web team, so I included this section just for you guys. You should feel special. Here we've got a data table that's representing the employee object that we created, and I'm just quickly populating that with rows. So something really interesting happens when you do a query on a data table. Here's our table of employees, and when we query it, we're actually getting a collection of data rows back. And just like how you remember how sum, min, and max was implemented on enumerators of integer, double, float, etc., there's this neat function called copy to data table on an IEnumerator of data rows, which actually copies this information straight into a data table and already predefines the rows for you, so you don't have to do that. So once your information is in the data table and you want to do LINQ statements, but then you need to get it back into a data table and not just be a collection of rows, you can do that very easily with this statement. Since you already know the syntax, this is going to be very familiar and very easy. Instead of using properties, you're going to use the column names or index operators for the rows. And here's just another example of doing this a little bit more shorthand. So if we wanted to loop over data rows that were in a new data table, you could call just @.asEnumerable.where, and that's quickly going to give us the information we need. And again, all the syntax you saw earlier, remember how I said link to objects, link to data sets, they're all using the same syntax. Everything you've learned previously still applies, but instead of using properties, we're just specifying the columns that we want on a particular data row. Any questions about that? Great. Just flying right through this. Okay, so link to XML. We don't use this really here because we don't use XML. But for those that don't realize it, working with XML and .NET used to be a pain in the rear, and I know because I did it. And then they introduced link to XML, and I was singing for joy in the rain. It was wonderful. It was a great day. Seriously though, on a side note, if you didn't realize this, one of the few things that VB.NET that has that C# doesn't is inline literals for XML. You notice that I'm actually writing XML straight into the code. Yeah, C# doesn't do that. So next time C# people are like, oh, C#'s better. Yeah, you don't have this. I mean, you've got everything else, literally, but you don't have this. Yes. And of course, we don't use XML hardly here, or at least in .NET this way. But if we ever are using XML to store things, you can use it just like link to data sets. It honestly looks very similar, except you need to know there's some objects out there, like XElement, XDocument, XAttribute, all these different types of objects that help you do this. But anyways, you can quickly get the idea here. If we wanted to get all the contacts nodes that have a contact within, I'm sorry, let me say this again. All the contact nodes that have another node within that of a name where the value is Patrick Hines, this would quickly return that. Again, since you didn't work with the previous XML documents and XML element objects, you don't know how nice this is. But if you have, you do. All right. So we're close to done. I just have a few other comments to make, namely about performance. Okay, so here's the deal, guys. LINQ, it's heavier than most things. It's certainly heavier than, say, just looping over the indexes of an array. And a lot of people will say don't use LINQ because it's more an expensive operation. And you shouldn't be doing that. You know, that's going to affect the performance. Well, I've got a statement here by a guy I found on Stack Overflow, which I just love. On the performance kick, if the performance of your algorithm is the sacred, uncompromisable first priority, you'd be programming in an unmanaged language like C++. .NET's already much slower than many other languages because of the runtime environment. And frankly, I would adopt the philosophy of it being good enough. LINQ may introduce slowdowns by its nature, but if you can't tell the difference, and your client can't tell the difference, then for all practical purposes, there is no difference. He makes a joke that premature optimization is the root of all evil in coding. I don't know if I'd go that far, but if you can make it work, then if you can make your code work using LINQ, then go ahead and do it. And afterwards, if you find it's too slow, okay, then look for optimization, okay? But the reality is, what you saw here today, all of that syntax, and all of the functions, etc., I think make for much, much more readable code, easier to maintain, and yes, it may affect performance a little bit, but that's like saying, well, this takes 50 milliseconds instead of 20 milliseconds. Come on. Nobody cares. It's not going to affect it. However, my general recommendation, if you've got a collection of over 10,000 objects, I want to be using LINQ. That's a really rough number, and it also depends on what you're doing to that collection. But if you've got 10,000 records of something, you're already doing something kind of heavy. However, I would say specifically, if you've got something over 1,000, if you've got over 1,000 records of something, I would just try to do order by and group by last, and I would also try to avoid using joins, because again, those are just the most intensive operations. They have to loop over everything. For instance, the order by uses the quick sort algorithm, which, while useful, isn't the fastest out there. Wow, James, you look sad that I mentioned quicksort. There's clearly some personal experience there. So, the moral of the story, always lean on DB2 for your heavy operations or your heavy querying, etc. But when you're in memory and you already have the collection of DB2, go ahead and use LINQ. And if you find that performance is a problem, or if Chad tells you that, or Jared tells you that, okay. Go back and pull the LINQ out and see if that can improve it. But honestly, you're probably going to already have performance problems, not because of LINQ, but because you're hitting the database too often, which is our #1 performance problem here at Elliott. So, in the future, my last statement that I'll make before taking any questions, if you find yourself in a scenario and you say, you know what, I've got giant collections here, and I really think LINQ would help me, and it would make the coding much faster, you need to go research something called p-LINQ or parallel LINQ. That's I can't remember if it was introduced in 4 or 4.5, .NET feature that allows you to take advantage of .NET's built-in ability to use multi-core processors. And essentially you can set up your LINQ statements to take advantage of that, and they'll be much faster. However, it's more coding, a little bit more, and it's something that I also haven't researched very intensely, so I'm not here to talk about it today. But it is something that exists, and I wanted you to know about it. Any questions? All right, fantastic. I hope to see a link in all of your code after this. Again, don't forget, this example will be out on the file server under training presentations, and so will this video. Thanks, guys.